Leetcode and make a host. Done. Okay.
Okay, so let me share it. Okay, so I forgot the problem numbers what were the problem numbers I sent, right? Let me open the email. Okay, so I sent you 10 the problem number. Yeah, it was 167. And okay, let's go to 167. Actually, sent, right? Yeah. So 11, 19. Okay. Okay. So let's do it. Hmm. 11. Okay. So we were discussing about that other day, right? Okay. Yeah. Okay. Yeah. So, okay. So, yeah, you wanted to tell me something.
So,
yeah, I can explain this solution.
Yeah.
Okay. Let me just.
Let me take a look at this.
Yeah.
That's.
Sorry. Yeah.
Yeah, that's a good solution. The only problem is that line 8, maybe you can split it into two lines, so make it easier because it's I know you put that formula inside this max function, but
for the readability, right?
Yeah. Maybe it is better to first get the area, then you update it with that variable, not with the
sure.
input function.
Okay. Okay. Yeah. So this is a 2-pointer problem, right? Yeah.
2-pointer problem. And yeah, other than that, I think it's perfect. So you know the key of this solution, right?
Yeah. I can explain. Okay. So the whole point is, so basically what happens is, so the first approach is a brute force method, right? So you take you start from the beginning, and you try to find out how much the water can be contained, start beginning from there, right? So here it is the water that can be contained is only 1:1. Okay, so if you take the first and the second, okay, the next, if you go here, right, So the water that can be contained is 1 into 2. Okay, and because it is limited to the the smallest bar, right, or a pillar, whatever you call it. Okay, so the same goes on the next one. So this one, right, though you have two, the one is smaller than two, first pillar is smaller than two, so you can only fill the water until one only, so it is 3. So so as we go till here, you can compute the area at every level, and try to find out the from the previous one, whatever the mean, you can have a variable of max area, and you can just try to compare whichever is the max, and then you can have that as a running area, and you can see which one gives the maximum area. Okay, so then you start from the next one. Okay, so you do the same thing. Okay, from this pillar to the next pillar. So this would be the area that can cover 6 into 1. And here, since this pillar is lesser than this one, right? So the area that can be covered is only 2 into 1. So this is a brute force method. So what we fundamentally see is the area that it can cover is actually limited by the lowest pillar. So we can use that one and try to see if we can use a 2-pointer here, right? So we start from the start here. Okay, we start from the beginning, start pointer, and we have the end pointer. So we see when you have that both the end, start and in the corner, extreme corner, what it can cover. So it will be in this case it is 1 into 7, 1 into 8. So it can cover 8, right? So so it is limited to this one, right? So we see whichever is a lesser, we try to move to the next one, right? Whichever is a lesser. So so now you see the area that can be covered is 7 into 7, so 49. Okay, so 49, there is a running area which right now the 49 is your maximum area, and so you see this one is the 7 is lesser than the 8. So we try to move to the next pointer here, so next pillar here, to see whether that will give you my better area. Okay, so here the area that can be covered is only 3 into 6. So that is 18, but it is not lesser than the greater than the current area. So we don't update it, right? So so we go to the next pillar. So this being the smaller, so we try to go to this pillar to see how much it can cover. So this is 8 into 5. So it is 40. Still the area is not, we have not reached, the area we had in the previous run was bigger. So basically we try to see whichever is the lesser, right? Whether if in the end pointer or the start pointer, we try to move that to the next pillar to see whether we can able to get a bigger area. So that's the whole idea of this max area problem. Yeah.
Yeah, that's a good explanation. Yeah, so I can see you understand this. So, but not only understand this, can you also tell me, so if you first see the problem, can you think about this? How do you know this is a question? You can observe the pattern and find out a solution like that.
Okay, pattern in the sense what I did not understand.
I mean, you know, imagine you don't know this solution and you first time see the problem.
Okay.
How can you observe this pattern? Because you have to know there's a pattern in this problem, then you will to look into the pattern, right? If you don't know there is a pattern for this problem that can make the solution much easier, you want to look for the pattern.
Maybe this two lines.
Yeah, and most important thing is that for this problem, you know that it's always starts, so the height is always the smallest height that will be the height for the area, right? So what I mean is that so from that you can see there is some pattern you can observe to make this solution easier. Then you will look into it. Then you find out that what you told me. Yeah.
Yeah. So in all the 2-point problems, we always use this idea, right?
Mm-hmm.
So whichever is the smaller, we try to go to the next one, right?
Mm-hmm.
So so this is the one we need to. So this is the commonality in all the 2-pointer problems, right? So so we try to do. This is your heart of your 2-pointer problem. So this is the whole business logic is there here, right? So we need to see if this is a pattern we should use to find this problem, right? Then it will fall into 2-pointer problem, right? That's correct.
Yeah. Okay. Yeah. Next question.
Okay. Next question is we'll see. Next question is 1119. Okay. So basically in this we are trying to delete the node. Okay, so we are trying to, from the nth node, we are trying to delete the remove the nth node from the end of the list. For example, here if we try to delete the nth node, right? So second node from the end of the list. The end of the list is so end of the list is here. Okay, so end of the list is here. Okay, so end of the list is here. From the end of the list, the second node, first node, and this is the second node. So we try to delete it. Okay, so the whole thing is the whole thing is to identify the second node. So if it was from the first of the list, the second node, it would have been easy because we go to the second one and we can just have to move the previous one to this one, right? The whole thing is it is at the from the end of the list. So that's where the challenge comes. Okay, so what we could we have to find. So here this is also a kind of a 2-pointer problem. So first, there will be a quick pointer, and also there will be a normal pointer. A quick pointer is where we where that node is already displayed to that nth node from the beginning. Okay, so basically this is this node is, so you start with the 2-pointer, first pointer and the second pointer. The second pointer being the fast pointer, that is first shifted to the nth node from the beginning. So it is pointing to the quick pointer is pointing here, and the start pointing is pointing here. Now we try to move both the pointer once at the same time, one at a time, so that the quick pointer will reach the end of the list before the start pointer. So that's the whole idea, right? So it will reach here for next one, and this will reach here. The start pointer will reach here, and okay. So when the start pointer is in the 3, quick pointer would have reached the null, right? End of this one. So now the start pointer is pointing here, right? So so now the start pointer will point to that point. So we have to see. So now we need to so wherever the start pointer is pointing is the next node is actually the nth node from the end of the list. So we need to remove this node. So now it becomes like a becomes like removing the node when we pass from the beginning. So now we can make this point here. So then it becomes easier. So the current node of next will point to the your next node of next. So that way we could remove the nth pointer from the end of the list. Yeah, correct. So this is what I have tried to do it. This again a 2 pointer, but we are not following that theory of moving decreasing something when on a smaller thing. But this is a 2 pointer problem, but it's a different variant. Yeah.
Yeah. So this is you create a 2 pointer, and one is a slower pointer and another is quicker pointer, and then
Yeah.
you go through that. Yeah.
Yeah.
And
So the
yeah.
only catch was this one, right? This dummy node, right? So
Yeah.
initially, what I did not have it. Okay, so for this one, well, I had to refer some the previous discussion here to address this one. So first, what I had was, so I started here.
Yeah.
Right, I started both here. Right.
Yeah.
I didn't have this dummy node, right? So I started here. So when this one this is quick and this is the normal slow pointer, right? So when this quick reached the end, this was actually pointing here. Slow and quick was pointing here. In this case, it is okay, right? It is okay in the sense it's not a problem. But I mean, the solution I would have created is now so slow of next will be equal to the slow of next of next, right? I would have written it. But the problem what happened was in this example, right? Whatever they have given. So the next one, so here, okay, and here, this is what is where the problem actually came. So so when the node that has to be deleted is the first node from the end, right? That means what happens is you are your quick node will be pointing see, a slow node will be here and quick node will be at the null, right?
Yeah.
Now you are supposed to remove this one.
Yeah.
You are on the node, okay? So you will not be able to you delete it. So that's the reason why you start with the dummy node. So when you start with the dummy node, what happens is you will land in the node previous to it.
Yeah.
Okay. Okay. So that way you will be able to delete it properly. Actually, in my previous example, I was wrong. So when okay, so in n is equal to 2, you would reach when you begin from here, right? Quicken the slow pointer. When you begin from here, you will the quick pointer will be here and slow pointer will be here. So you will be actually have to maintain a previous node, and then that previous node of next has to point to this one. So this was a solution, but this solution has a fault in when the last node has to be deleted. So when n is equal to 1. So to address that, you need to start with the dummy node. Okay. So dummy node is actually I didn't get that idea of starting with a dummy node. I had to refer to some discussions, and so then only I got that idea. So
dummy node is the node. It is the node before that linked list.
Yeah, dummy node is this one. This is a dummy.
That is a very that is actually a very practical way to do this kind of problem. So next time when you see a linked list problem and you have to go through those pointers, remember you always do that. Always use a dummy node. That's not only for this problem. That's a very general problem. Yeah.
I see. Is it like a Python thing or something? Because
no, it's not Python. If it's even a JavaScript or Java, you also need to use dummy node.
I see.
Yeah, it's like a tactic to solve these kind of problems. Not only this one. There are a lot. I have seen a lot of these kind of solutions. Yeah.
Okay.
So looks like you know about this now. So basically, you first create a quick node, and then the quick node. So you always jump through that n node. So the n it gives you, because then you create a slow node, and slow node and quick node starts to go together until the quick node reach the end. Then the slow node will reach the end, reach n node from the end, and then you remove that node. And the tricky part is using the dummy node, and that is a very common thing to do that for these kind of problems. Yeah.
Okay.
Yeah. Next question.
Okay. Next question is 26.
Yeah.
So remove duplicate in the sorted array. So what this was like. Okay, here if you see, okay, so what I approached was, I didn't look at the solution, but I just tried because it was kind of an easy problem. So so you start with the this first, and so it's also a kind of a 2-pointer problem, right? So but in a but you need to find the condition. These are the condition, right? So if you are so your you start with the first and the second indexes, and you try to see whether they are equal, right? If it is equal, you try to move to the next one, because you are until you get a different one, right? You don't move the first index, right? So basically, you don't move the first index. So once you hit a different number, so you are still in that so mismatching, so matching index, right? Whenever, basically, let me explain it from the beginning. Okay. So what the basic idea is, whenever you hit a similar numbers, right, with the comparing numbers, so you start moving the next pointer until you hit a different number. So you start from here, right? You start from 0 and first index, and you are hitting a same number. So you don't try to move the first index. Okay. So you try to move the second index until you get the similar dissimilar number, right? So here 0 and 1 you got it, right? So that way you got a dissimilar number. So your first index is pointing to the position where you saw the similarity. So you move the first index so that you can copy that value here. Okay. So now you have a 1. So your first index is here. So now you will hit similar index. This one and this one will be again 1. This one and this one will be 1 again. So until you hit the 2. 2 you saw 1 and 2 are different. So you try to copy it into the first index plus 1 position. So this will be 2 now. So it will be 0, 1, 2. But now the quick index the second index will be pointing here. So now but the first index will be pointing to this position where you have copied the 2, right? So until you are able to find move until you're able to go till the end of the list. So you will be copying all the similar all the duplicates, remove all the duplicates, and you know where the first index is pointing. So that is your length of the list. So basically you return till there. Yeah, that's the whole thing.
Yeah, your solution is good, but the only problem is that it can be easier actually.
I see.
This problem. You know why it can be easier is because this problem doesn't want you to return the exact list, right? So it only wants you to return the length.
Yeah.
Because it only wants you to return the new length. Therefore, you can actually let me send you my solution. First thing first is that your if statement, it doesn't really matter practically speaking, but it is a way of showing how you think. So first, you have to think about the boundary cases, right? So you think about when the length of nums is equals to 1, you return the length of nums. That's good. But you have to consider all the boundary cases. Is there any other boundary cases?
Length of nums equal to 0.
Yes. So that doesn't matter in this problem, but it's a way to think. So when you think about boundary cases, you always try to cover all the boundary cases. That's easier. And let me send you the solution. Okay, take a look. I send you through the Zoom.
Yeah. Okay, so yeah, so return 0, I return, okay. So yeah.
So because it is a sorted list, right? So the nums of I plus 1 is meant to be bigger than nums of I. Therefore, the current number will plus. In this case, it's a normal case. And also nums of J. So it will, nums of J is used to insert elements to the array. Therefore, nums of J will be nums of I, and J will increment. Eventually, we will assign nums of I plus 1 to nums of J. And then we return J plus 1, because J plus 1 will be the total length of a list without any duplicates.
Okay.
Is this solution more concise?
Yeah, correct.
Yeah.
So let's see. Okay, I plus 1. So the next one, right?
Yeah.
So you're trying to move this next one. So if it's less than if it's If it's lesser than that, you just try to increment. And yeah, so J is, oh, you're running it in the loop, right? So this one is in the loop.
Yeah.
And yeah.
They're all in the loop.
Yeah.
Mm-hmm.
Okay. Okay, I see what you're saying.
That
Okay.
is the, so that line 18 is that when it's not in the if statement, when the situation is not correct, then we will always assign nums of I plus 1 to j, which we will delete that duplicated
Yeah.
element. Yeah. Yeah, because when I solve those problems, I don't only think about the solution, then I pass it, that's all. I always compare different solutions and find the one that's more also readability and concise and good algorithm. Yeah.
Yeah. So I will, yeah, this is a better way to do it. Yeah, that's correct.
Okay.
Yeah. So let's, like, should we move to the next one?
Yeah. Move to the next one. What's the next question?
Yeah, actually this was an easy problem. So to some two input array is sorted, right? So yeah. Basically you so I try to okay, so if it is it's again a 2-pointer problem.
Yeah.
You start with the first and the last index, and until your start is less than the end pointer, you try to see whether you can make the sum. Okay. If it is lesser than your target minus num end pointer, so you move the whichever is the lesser, you try to move the start pointer or the end pointer. So that's it. So 2 plus 15 is 17. So it is actually the 2 is lesser, right? So you try to so target minus end pointer, right? So it is 9. So you try to move the move the 15, right? Move 15.
Yeah.
So it will come here. So so then 2 plus 11 is 13. So 13, so it is still not equal. So then you try to see if that the target is target minus the end pointer, right? 9 minus 11. So that, so start is greater. So you move the to 7, right? So 2 plus 7, right? So it is 9. So yeah, so that's the reason why. Yeah.
True. Yeah, that's very good. So basically, it's like set up a point from left and right, and you start going through that, and based on the sum is bigger than target or smaller than target, then you keep that will decide way to go. Yeah, that's a good solution. And just a little bit about your code is not very concise. There's a little bit you can change. Let me show you. So the line 9 and the line 10 and the line 11, actually you don't need 3 lines. You just need 1 line of that. So let me give you that line. Let me write that down. Start point +1 and end point. That's probably a Python thing, so you don't know about it. So basically, line 9, line 10, and line 11 can be replaced by this line. Yeah, if you take a look at the Zoom chat.
Oh yeah.
Yeah, it basically can be replaced by this one line of code. Yeah.
Okay, so you say this one as a yeah.
Yeah. That's basically
Yeah.
and yeah, that's basically it. If you run the code, it will work. I'm pretty sure. Yeah. Yeah, if you submit it.
Yeah.
Because that is only this. Because if you look at the logic of your code, it can not work. Have you noticed that this code cannot work? It's like if you have a data that's not going to have two values adds up to that number, the code will return error message because it will return an error message, and the error message will in your case it won't because you have defined a target indexes variable. Actually, you don't really need that target indexes variable.
Yeah.
Yeah.
But what if the list is null? So if we
yeah, if you remove that line 6, just remove the entire thing, just to make it easier, more concise. You should always think about how to make your code more. And on line 17, and just change the target indexes to -1, which means there is not a solution variable. So which means there are no two numbers adds up to the target. So that's a error message -1. Then you submit it. It will still work. Yeah.
okay, unindented, right?
Yeah. That's the indentation. Yeah.
Okay, here. Oh, you know what? You need to return a list. You need to return a list.
No. This is an indentation problem. So indentation problem is because your which line? Let me take a look. It's indentation problem. If you just move that return to the left one block.
Okay, let's do this.
Just move the return to the left one block. Do you understand what I mean?
Yeah,
so, yeah. No. Move to the left. Yeah. That should work. If you submit it now.
No, because it should not be in the while loop, right? You should be in this level.
Yeah. Submit it now. Yeah. You see? So that code is more concise, much more concise than your code, and
yeah,
more readable. Yeah.
Okay.
So now.
So is there any coding practice book like so where I can see this? How do I get these kind of like precise way of writing? Is there any way I can?
Oh yeah. That you can learn from experience. So it's not there are not many of those kind of things. But so you basically do you know like iteration, like Python iteration? there are some ways that you can do like a for index and the value element in something like that. So you can
I think okay.
Relation.
No, I'm not getting all the chat of yours. Wait a minute.
Yeah, I'm sending you something like that. So that way, there are not many of those kind of things, but if you just learn from experience, then you know this kind of thing. So for example, this kind of statement that is used when you need the index and also the element, but you don't want to separate those, but you don't want to mix those two, so you want to separate them, and then you can use the index and elements all together separately, you know?
Mm.
Yeah. So, and other things is that in Python, you can return those values. So basically it's like the line 8 on your solution. And also another thing is that expression we talked about last lecture. So we talked about that return something if something else something, right? Something like that.
Yeah, these kind of things, right? Yeah. So
So,
iteration, yeah.
Don't worry about it. There are not many of them, so don't worry about it. So just learn from it and practice, then you can.
Yeah, correct. Yeah. So that is all the homework problem. So how do we
so basically after those questions, I would say you have almost know the basics about two pointers, this topic. But now what you need to do is associate a problem with two pointers. So you tell me what kind of problems can be solved by two pointer.
Okay, can you what kind of problems is it has to involve moving of two indexes, right? Then it can be classified as a if something which can need to be okay. So there are and two pointer is kind of an alternative to a brute force, what we can think, where your n square solution becomes the order of n because of the using the two pointer, right? And that's the way I understood. Yeah.
Okay.
So the same thing, right? For example, here you could have written two loops, right? Until we get that target, we could have just looped this twice. Yeah. Then also we would have got in the same thing, right? Here the key player is the sorted, right? When it is sorted, we have to make use of that sorted property of that, right? So when we make use of that sorted property, that's when this one we are able to do it. Yeah.
Okay, so basically a two pointer is something when you need to set up two pointer, and then so the two pointers position can be one in the beginning and another in the end, or two pointer can be one is quicker than another one.
Yeah.
Right. So I'm not sure. Have you solved a problem like that? That's another two-pointer problem. Actually, I thought of. Let me search about the problem. That's a very interesting problem. Let me see. Circle. Linked list circle. Have you heard of a problem like that? Linked list circle.
Yeah. So finding the list of the Yeah, I think I have heard. Okay, let me try to tell you what I know.
So the problem is one for one. Linked list.
So basically, if there is a linked list, you need to find whether it is a it's circular linked list or not, right? Yeah.
So basically,
there is a loop. There is a loop in the. I think there is a loop in the linked list or not, right? So something like that.
Yeah. So basically, to solve this problem, you can use a lot of methods, but most of them are complicated. But you can use two pointer. Do you know how to use two pointer? So basically, you set a pointer that's quicker than another one. So you set a pointer that's moves quicker than another one. Also, in the front of that another pointer, then you see if two pointer will meet again. If
I saw this filter tag.
It's like two people running in a marathon or something. So if there's no circle, so the quicker one will always be quicker. So they will never meet. But if there's a circle, so the quicker one will.
Circular area loop, right?
Yeah.
This one.
Yeah.
Is this the one? No.
Not this one, but as long as you know the idea, that's good enough.
Yeah. Okay.
So today, let's go through another topic, which is a little bit. Let me think about what topic today, because there are topics that's quite difficult actually. Okay, today let's talk about mathematics. So go to question 172.
Okay, given an integer, return number of trailing zero in n factorial, right?
Yeah.
Could you write a problem that works in the logarithmic complexity? Okay, so number of trailing zeros. Yeah, so we can find the factorial first and then try to find out how many zeros are there. Or another way to do it is, so the number 5 into 2 or if there is a 10, so those are the number of zeros it can give, right? So will lead to 0. Oh, I mean, let me tell you my point, right? Yeah.
So what's your strategy again?
Okay, let me just tell you, right? Yeah. So zeros, right? So when you multiply something to have a trailing zero, you can achieve by 5 into 2, right? Because it gives you 10.
Yeah.
Or it should be 10 into some number, right? So that will give you 0. So basically, so 1 into 2 into 3, right? 3 factorial, right? So 3 factorial does not have this combination or this combination. So there is a 0 trailing thing. Okay.
Okay. So first, if think like that, then 5 multiplied 2 is equals to 10, which there is a 0, and 10 multiplied a number will be 0. What about 20?
Yeah, 20, right? So basically, you're trying to see multiples of 10. So basically, this is a multiples of 10, right? So that is what I am trying to say. Or it is basically you're trying to find out here 5 into 2, right? So if you could get into multiples of 10, or it is here in this case 5 into 2, right? So your number, it can be like like 25 into 4, right? Can also lead to 2 zeros, right? So basically you have to see whether it is 5 into 5. So you got to look for, first you got to look for 5 multiples,
Yeah.
2 multiples, and 10 multiples, right?
Okay.
The
So I have okay. I have no problem with 5 multiples and 2 multiples, but I have a problem with 10. Why do I have to look into 10 multiply?
No, you don't need to look at 10 multiples. You can count it itself, right? You can count. So you can count your, so if you can count the zeros directly for the 10. So that you can do it without doing the multiples, because so 10 or 20 or 30 or 40 is going to give you 1. 100, 200, 300, 400 is going to give you 2, right? 2 trailing zeros. So we have to look for 5 and 2 multiples only. Okay. So let's see how I can do it. Okay.
And another thing is that you can think about it. Do we need to look at the number of 2 multiplies? Will 2 multiplies everywhere? Because 2, as long as a number is an even number, you will have 2 in the number, right?
Yeah, that's correct.
For example, 2, 4, 6, 8, 10, or 12 and 14, they are all 2 in those numbers. And basically, if you have a number, there will be a 2 combined with it, right?
Yeah, that's correct. So that means, so if you take 1, 2, 3, 4, 5, right?
Yeah.
And for this combination, you will get one trailing 0, right?
Yeah.
So so 6, 7, 8, 9, 10, you get one trailing 0. So if we map it to the next level, if you map it to the next level, can we map like 11, 12, 13, 14, 15. Okay. This will again lead to one trailing 0, right? Similarly, 16, 17, 18, 19, 20. One trailing 0. Okay. So can this be, can I hold after 100? So it will be 100, 1, 2, 3, 4, 5. So this will give you one trailing 0. And 6, 100 will give you 2 trailing 0, right? So it will give you 2 trailing 0. So basically for this one, the logic would be, so if you're, okay, so I think I have some thing here. Let me put it. Okay, so basically what I'm trying to say is, when so basically what you need to do is n, right? So you need to reduce 5. So basically you try to do it minus 5, right? So at everything, and then you compute whether what is your number, right? So basically, if it's less than, yeah, and then you compute the trailing zeros. So you have a trailing zeros equal to 0, and this is your number. So here you got to do n minus 5, right? N is equal to n minus 5. You subtract every 5. So this is between your running uh, equal to 1, right? So running num. So basically this is running num. So it is okay. So yeah, n mod 5, right? So equal to 0. Then it is there is an outstanding 5. So outstanding 5 equal to outstanding 5 plus 1, right? So when mod 2, right? 2 is equal to, so n mod 2 is equal to 0. So then it will become outstanding 2. There's an outstanding 2. Okay, so there is an outstanding 2 if so else if so n mod 5 is equal to 0. So then if outstanding 2, then you need to say it is trailing. So make the outstanding 0 to 2 to 0, and trailing zeros plus trailing zeros plus 1. Okay, so basically you accounted for 5 multiple and 2 multiple. Now you see if it's a 10 multiple, right? Else if so you have to subtract n mod 10 equal to 0. So now so it's not else if, it's else if, right? That's the syntax. So n mod 10. So now it is number of zeros, right? So basically you need to calculate the number of zeros here. So Yeah.
Okay, so looks like the time is almost up. So I'm going to tell you about, give you some hint about this question, and then I'll let you think about it, and I'll give you more questions related to math, so you can solve as your homework. Okay. So this question, your idea is good. Your idea is good. Just you did two unnecessary things. So first thing, you don't need to count the number of 2. And the second thing, you don't need to count the number of 10. You only need to count the number of 5. Why? So first, the 10 doesn't matter because 10 is just the 2 multiply 5 is 10. If you need to count the number of 10, then you need to count the number of 15. Then you need to count the number of 20. But you don't. You just need the basic multiplier. So basic multiplier in this case is 2 and 5. But why you don't need to count the number of 5? The number of 2 is because 2 is everywhere. So we can guarantee, it is guaranteed that 2 is more than 5, right? So the number of 2 multiplier is more than number of 5 multiplier. So the reason we want to make sure that there are enough 2 multiplier is because if there's not enough 2 multiplier, 5 will never have a trailing 0, right? Because 5 only multiply 2 will become 10. So that will add to the trailing 0 if you multiply them.
Yeah, I got it. So even 10 will be 10 will be divisible by 5, right?
Yeah.
So yeah.
And about the 2, because we are sure that there are enough 2.
Yeah, I think you can simplify. Sorry, it's getting late for you. I'm just trying to see if this will work.
Yeah.
So if it's okay, so I think I think I got your point. So I will remove all these and then say only n is equal to 2, right? So if you have a 5 multiplier, then you have already moved past the 2, right? N minus 2. So now we need to determine whether it is 5 or 10, right? 5 multiplier or 10. So if it's this one, then you have to see if so if it's n mod 10 equal to 0, then it's we need to see this is like it is divisible by 10 and also 5. So that means it is multiples of 10, right? So else trailing zeros equal to trailing zeros plus 1. So here it has to, we need to see if it's so this has to be looped to find out how many zeros are there, right? So I think yeah, this is what I think you're trying to say, right? You're right.
Yeah, something like that. But you still don't need the number of 10. You just, so first I will I will let you think about it first. So
okay, sure.
Very, very concise. Yeah. Okay, so now I will use the time and give you a list of questions as homework. So
sure. Yeah. Okay, let me put it in your fire. but I don't.
I will send you through Fiverr.
Yeah.
For next session, be a few questions. Okay. Okay, so I delivered this work, and also in my deliver note, there's a question list, and you can take a look.
Okay, there is a question list. Okay, yeah, that's good. So here, right, there is I have one more thing. So can I do some more two-pointer problem, right? Can I just solve two-pointer problems? All the basically try to solve all the high frequent two-point problems.
High frequent, yeah. So the two-pointer questions, you have solved. They are all classical questions, and I suggest. So, are you doing a Leetcode weekly contest, by the way?
No, I am trying to solve all the problems of all the FANG, right? So that is my.
I suggest you to do a Leetcode weekly contest every Sunday, because in that way, because you will encounter problems. Usually there are 4 questions for each contest, and those questions are new, and then you can look at the questions and think, oh, can I solve it with two-pointer, or can I solve it with another topic? That way you will associate the question with the topics you have learned. That's a good way to practice. And another thing is that if you want to solve more two-pointer questions,
where do I get that contest? Where do I see that?
What context?
No, you said the weekly contest.
Oh, yeah,
right?
yeah. So the weekly contest. If you look into your Leetcode homepage.
Yeah, I'm there.
Homepage, yeah. And there's a contest tab.
Yeah, there is a contest tab.
Yeah.
Yeah.
Go to contest and join the most recent contest, which will start January 17th. 17th of January, join that contest. And
so bi-weekly context, join this. It says January 23rd, right? Oh, here, weekly context, January 16th for me. Yeah.
Yeah. So you can start joining those contests and try your skills. So basically, you will see different questions, all new questions, and then new to everyone. And then you need to apply the topic that I taught you. Yeah. Okay. So about the two-pointer questions, I will find some two-pointer questions for you if you want. But let me tell you that like two-pointer is not really a difficult pattern to.
I see.
So you need to practice. So basically, all those questions, if you really understand the questions that I taught you this lecture, you will I think you are okay with all the two-pointer questions. It's not a very complicated topic. Yeah.
Okay.
Yeah.
Okay. Sure. Hey, next time can we just do like a little go into like go from array and list? Can we move to like trees, graph, and some little more complex data structure? So after the math, right? Yeah, maybe
but,
slowly move it. Okay. Yeah.
Don't do
Yeah.
that. So I have like, so I have this all planned out. So from easy topics to difficult topics. So you have to
Okay.
go through. So you have to cover everything. Otherwise, if you haven't seen a topic, then you don't know how to associate that question. Then you will fail in the interview. That's so you need to cover everything eventually. Yeah.
Yeah, yeah, sure, 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 sure.
Okay.
Okay.
Thanks.
Yeah. Tomorrow I will not be able to do it, like it's too quick, but can we do it I will start this I'll buy it now, but can we do it like Friday or Saturday, one of those days,
Sure,
right?
sure, sure. Yeah, do it on Friday or Saturday. Let me know in advance. Yeah.
Yeah, yeah, sure. Yeah, I will deliver this one and I will buy it immediately. Yeah.
Sure. Thanks.
Thank
And
you. Hey, last time delivery you got, right? You got the last time
last
delivery.
time the delivery, yeah. I get the delivery, and maybe if you like, you can add some good comment after delivery. That will be appreciated. That would be great.
Yeah, sure. Yeah, I get that page. I will try to do it. Yeah, I'm not like good in writing.
Yeah. Just
But
write
I'll try
something.
to write. Yeah,
Good
sure.
comment. Yeah. Thanks.
Yeah,
Okay.
sure.
Have
Thank you.
a good day. Talk to you
You
soon.
too. Bye bye. Yeah, bye bye.